Hi, I'm Elle. So far in this series, we've been talking about using continuous integration tools like GitHub Actions to automatically train machine learning models whenever your data set or your code changes. Now, you can actually get a lot of the power that we've talked about if you only test your models automatically. What I mean is you can still develop your model locally, maybe using kind of an interactive console or Jupyter Notebook or your favorite experiment tracker, whatever. And then simply check in your favorite model into a GitHub repository at the end of the day and run a suite of automated tests on that. And that still gives you a lot of the value. So what we're going to cover today is how to create your very first automated check. Basically, does my model run somewhere that's not my local computer? And the value of doing this is that testing your model locally isn't really enough. It's not rigorous enough. You often don't know completely what's on your machine, so you want to create kind of like an airtight scientific check where you really know what was the environment, what was the hardware, what was the operating system, what was the code, everything that went into your test, and then make that available in the historical record of your project for everyone on your team. And doing this can really help speed up development cycles in the long run. It's a really cool practice. So let's jump into making your very first automated machine learning model test. All right, let's take a look around our project repository. We've got a training script, which is going to build a model. I'm generating some synthetic data, establishing a linear regression model, and I'm going to save the model by pickling it. Then I've written one kind of test. The test is very bare bones. All it does is load the model, generate some synthetic data, and do inference on the model. We're not assessing any statistics whatsoever about the result. We just want to know, does this complete? And ideally, we would like to be able to test that whenever a change happens to our code about the model. And so I've created a GitHub action to do that. So GitHub Actions are a way to automate workflows that you create. So this is a GitHub action config file. It's saying that whenever a push to the repository is detected, GitHub is going to spin up a machine, a runner, that will have the Ubuntu operating system. It's going to pull a Docker container that I've specified. This is my Docker container from the CML project, but you can use your own. And then it's going to run this workflow. It's going to install our requirements, and then it's going to run python test.py. So the test is essentially, can I operate, can I do this command right here? And that's kind of it. So if I go over to my local workspace where, say, it's been a long day interactively developing my favorite models, getting really deep intuition about the data, and I have all these hypotheses, and I come up with a model that I'm really thrilled about. I'm working on an experimental branch, and I've created a new version of the model. Mainly what I've done is I've just changed the model from a linear regression to a lasso, but we can pretend that that is a super deep insight. And so I will train my model, and it could be that I've trained many models locally that day, but eventually I get to one that I like, and when I have that in my working directory, I want to snapshot this and send this to my GitHub repository. And the reason I'm going to do that is because of when I push this to the GitHub repository, it's going to run that test script for me. I could run it locally, but then it's not really shared with anybody else on my team, and I don't fully know all of the constraints of my local machine. I don't really know. I can think I know, but it can always surprise you. So let's see. I'm going to do git add, and I will commit my favorite model. All right, we are pushing, and now we can go back to GitHub, and if I refresh, you should see, let's make a pull request. Okay, so now we can see that something is running, and that's because of my GitHub Actions workflow. And if we're lucky, this little yellow dot will turn into a happy green check mark. If we're not lucky, then it will turn into a terrifying red X, and we will have to go investigate. So we shall sit and wait. We'll take a minute. Oh, we got the red X. Okay, So we'll go investigate. We go look into details, and we can take a look and we'll get the log, and we'll see that it seems that we failed because of a module is missing. That almost always comes down to our requirements file. And we can see that indeed we have left out the scikit-learn library. So we'll open this up. Actually, let's switch branches first. Open this and add scikit-learn, and that should do it. Now, if I have, a team where our environments are often complex or maybe conflicting, I might check in with them, have somebody take a look at this and say, hey, is there any reason why this would be bad? But it's just me, so I'm going to add scikit-learn to the requirements, commit that, and then hopefully it will run this time. Okay, we wait yet again. Okay, it still didn't run. Okay, let's take a look. So we go here, back to our logs. The error that we've hit has to do with our input dimensions to the model. And well, I did this on purpose. You might have caught this, but I don't know if you saw, but our model is trained on 10 features, but in the test, we expect 11. Now, I don't want to modify the test because presumably we made this for a reason, and if this were a more complex problem, the test might be something to do with how data looks like in, what's really coming into our system and the format that it's in, and so I don't really want to modify that. So what I'll actually do is go back to my training script. I will change the number of features, and then I will retrain my model. Python train.py. There we go. I will retrain the model, and I will say that's because I need to pull right. Boom. All right, let's head back over to our pull request one more time. I think we got it this time. And now we wait and we see what happens. See, look at this. Look at these sorry, sad red X's. It's extremely motivating to follow all the way to completion and keep iterating till you get it right. If you are wondering, as a child, it was extremely easy to motivate me with like stickers. Like, yeah, I just want the nice little star. Well, I did a good job. Oh, there it goes. Okay, we did it. We got the green check. So why did we do this? Now we have a test. We know that this one time the model was able to run an inference, and we also know exactly what it took. We know about the operating system. We know about all of the packages that had to be installed. We know the Docker container. And if we really look through the docs, we could figure out what was the hardware that GitHub was using on their runners. So we've pretty much got it all in one place. And if I have a team, then this GitHub repository is accessible to everyone. So I've kind of standardized my check of, the most simple question of, did the model work at all? Whether or not it does a good job is a question for another day, and something that we'll be answering in the next few videos, thinking about how can we develop more interesting tests that we can report whenever we're checking in a model. But just for today, we can celebrate. We have the green check. Thanks for watching, everybody. Let us know what you think. Questions and comments can, as always, go in the comments, or you can drop by our Discord channel, where we are always happy to provide you some support. Subscribe and share, and definitely let us know what kind of content you want to see. If there's any kind of explainer or tutorial that we can make that will help you, let us know. All right, thanks for tuning in, and we'll catch you soon. Bye.